For today, we're going to be looking at the subatomic particles that are located inside the atoms, and specifically we're going to be looking at their locations, their charges, and their masses or sizes. This is mainly a review from 8th grade, so here we go. The building blocks of matter, atoms. So again, matter is anything that has mass and takes up space, and that's called volume. For example, a brick has mass and takes up space. A desk has mass and takes up space. A pencil has mass and takes up space. Air has mass and takes up space. So all of the above examples are considered matter because they have mass and take up space. The only two things in the universe that don't have mass and take up space are light and energy. Matter, again, as we learned yesterday, is anything that takes up space and has mass, and it can be found in several different states: solid, liquids, gases, and plasmas. So let's look at the subatomic particle of atoms. Atoms, again, are the smallest possible unit into which matter can be divided while still maintaining its properties. What that means is that an atom cannot be divided, but you can definitely tell each different atom from the other atoms based on its properties. For example, gold atoms have their own properties, which are different from, say, example, neon, which is an atom that has its own properties. So each atom you can differentiate between the atoms based on their properties. So there are several different subatomic particles that we're going to be looking at. We've got our positive protons, which are located inside the nucleus of the atom. We have our neutral neutrons. They have no charge. That means they're not electrically charged. They're not positive or negative. And they're also located in the nucleus of the atom. And then we have our negative electrons, which are located in the electron cloud, or the energy levels outside of the nucleus of the atom. Now, it's very important to note that we're looking at an atom, and an atom is electrically neutral. So that means that it has an equal number of positive charges and an equal number of negative charges. Atoms are so small that it would take a stack of about 50,000 aluminum atoms to equal the thickness of a sheet of aluminum foil from your kitchen. So that is tiny. A human hair is about 1 million carbon atoms wide. A typical human cell contains roughly 1 trillion atoms. So I think you get the idea. It would take you about 500 years to count the number of atoms in a grain of salt. So they are super small, but you can still tell which atom is which. So let's look at protons first. Again, our whole purpose of the day is to look at these different subatomic particles, where they're located, what their charges are, and how their size, their mass. So protons are inside the nucleus, that's their location. They have a positive charge and an average mass, which we'll talk more about in a minute. So they help, the protons are always used to identify which atom it is. So if you have an atom, for example, that has 5 protons, and you know what you know about the periodic table of the elements, you already know that if it has 5 protons, then it's a boron atom. So if it has 1 proton, it's hydrogen. If it has 2, it's helium. So they also often call the protons the DNA of the atom because they help identify it. It is equal to the atomic number of the atom, which we'll talk more about later. Sorry about that. So we're going to be looking, it says it's equal to the atomic number of the atom. We're going to look more at that tomorrow. It contributes to the atomic mass. We'll talk more about that tomorrow. And the fact that it's equal to the number of electrons that are found in the atom, that is because they know that because protons are positive, and you have an equal number of negative electrons. So that is just something that they know for a fact. The second thing that you're going to find, the second particle that you're going to find, is the neutron. The neutrons are also located inside the nucleus of the atom, but they have no electric charge. They're completely neutral. And they contribute to the atomic mass. And we'll talk more about that tomorrow. But for today, you should know that protons, which are positive, and neutrons, which are neutral, are both located inside the nucleus of the atom. And you can see, if you look, that they have about the same size. They're about the same mass. So let's move on to our electrons. Electrons have a negative charge. So that's their charge. They are found outside the nucleus of the atom in the electron orbits or levels, and they are equal to the number of protons. So inside the nucleus, you have these positives. Outside in the energy levels or orbits, you have these negatives. Electrons move incredibly rapidly. There's no way that you would be able to see them moving, and they move so fast that they create what we call the electron cloud. They have a pretty insignificant mass, and what that means is they are much, much, much smaller than the particles that are inside the nucleus, including protons and neutrons. They're very, very tiny. And again, because the atom is electrically neutral, the number of negative electrons is equal to the number of positive protons. And yes, electrons are involved in the formation of chemical bonds, but we're not going to focus on that today. So now that we know where all of the subatomic particles are located, and again, positive protons are inside the nucleus, neutral neutrons are inside the nucleus, and negative electrons are outside of the nucleus, let's look at their sizes. Now, on the slide, it says atomic mass unit is defined as 1/12 the mass of a carbon-12 atom. We don't really need to worry about what that means, but what we do need to look at is that 1 AMU is representative of, or atomic mass unit, is representative of the size of one proton. 1 AMU is representative of the size of a neutron, and the electrons are so small that they don't even register. Their mass doesn't even register on the AMU scale. So please notice again that protons and neutrons are about the same mass, while electrons have almost no mass. If you did a weight comparison, this is how it would work out. Now, it's important that you be able to look at these three numbers right here and determine that the neutron, which is 1.6749286 times 10 to the negative 27th kilogram, is approximately the same size as the proton, while the electron is much, much, much smaller. You can look at the numbers and tell that. If you look at these scales, this is what it would approximately weigh out to. It would take 1,839 electrons to make up the size of one neutron. It would take 1,836 electrons to make up the size of one proton. I'm sorry, that's a 9. So basically, how do you think the mass of a neutron compares to that of a proton? They're just about equal. They're just about equal. If you look at this chart, again, you can see that size comparison. You've got a single atom over here. You can tell that the nucleus makes up about 1/10,000th of the atom. The protons and neutrons are inside of the nucleus, and they're about the same size, while the electrons are outside, and they are very tiny. It's important to note, however, that most of the atom is made up of the electron cloud. It's so big and so massive to have all these little bitty tiny particles in them. So the nucleus is the biggest, but the electron cloud makes up most of the atom. So again, the atom center, the nucleus, you've got your protons and your neutrons. They're about the same size. The protons are positive, the neutrons are neutral, and then outside of the nucleus, not a part of the nucleus, you have your negative electrons, and they are very tiny. They're negative, and you can tell that this particular atom has 1, 2, 3 positives and 1, 2, 3 negatives. This means that they are it's an electrically neutral atom. This is what you're going to find on the periodic table. So, just to recap, the atom is made up of 3 subatomic particles. Protons, which are a positive charge and located inside the nucleus. Neutrons, which have no charge and are located inside the nucleus, and the protons and neutrons are about the same size. And then you have your electrons, which are located outside of the nucleus. They have a negative charge, and they're super, super tiny. It's also important to note that the number of positive charges in an atom is the same as the number of negative charges, and you can use the number of protons to tell you which atom this is. And this particular atom has 1, 2, 3 protons, and I happen to know that that is a model of a lithium atom. Okay? All right.